All right, let's begin. Welcome all. I'm Nikhil. This is my founder Gokul from CynLr. We wanted to do a little more than a pre-placement talk today. We wanted to really welcome you all to our laboratory and also tell you about our story. What are we really solving? What is the opportunity that we are trying to address? The big picture of what CynLr really is. And that I'm sure will give you the right perspective to understand whether you see an opportunity in working for us or working with us, so to speak. So we'll not waste a lot of time. Let's go ahead get started. We will be sharing a presentation live with you. Gokul and I will take turns to discuss different parts of this presentation. Quick housekeeping, there is a Q&A section on the platform at any point in time. If you want to register your question, you can type that in. We have a moderator who will look at that question, and at the end of the presentation, we will take up these questions, and as much as the time permits, we will be able to address as many queries as possible. So great, so let's get started.
Once again, welcome all, and without much delay, let me begin with our journey, right, and story. This is actually a very famous ad that came in our 90s and early 2000s. And what you saw here is not about Motilal Oswalt, right? What you saw here is a sequence of actions that we keep seeing, and the whole world that is built beyond the software that has been built, or the desks that we actually sit in, which is a lot of coordination between the eyes and hands, right? The manual labor. Now, if you just look at manual labor again, across all these variety of tasks that we actually saw, right? Be it putting parts together or wires or your warehouses and whatever that you might actually think about, from a construction to your food processing to anything, you see that people are constantly doing these three actions, right? If you just break all this variety of tasks, right? It's just picking, orienting, and placing, right? And we always hear automation as a word associated along with it, right? And automation is being prominently being spoken about. That's the basis of most of engineering that we actually do. And the world hasn't been quiet about solving this. This has been quite well known as a problem and active field of study always. And we have progressed significantly, right? We keep hearing about how AI is today and how our Google AI is able to dream, right? And we have seen robots from Amazon's Pick Challenge helping in the warehouses to do the last mile, the pick and place of the objects, and then packaging systems, right? And we also have seen obviously the star of all the robotic arm, or sorry, the robotics world, as it's the Boston Dynamics and things. This was a very positive narrative that we had, and people had been actively talking about how AI is going to rule the world and how it's going to take over most of those portions, right? Which is really great. But suddenly, after a few years, a lot of story has changed, the perspective has changed. Suddenly, the doomsday has been moved over and then been spoken more about how we are not there yet and how limited is our automation. It might be a lot of hype, and we may not be there yet, right? But in fact, if we have to statistically understand this, right, beyond what we actually hear, because we are surrounded with a lot of different perspectives and opinions, right? If we have to just step a little bit into the statistics, right, The 2017 McKinsey report clearly states that around 31% of the time spent, it's about the time that has been spent. What do we mean by that? To make a product, you have variety of different tasks that happens on a day-to-day basis, right? So if you go into a manufacturing plant, and in fact a precursor to that, if you just look around you, every object that you actually utilize today, right? Be it the food that you eat, to the spectacle that I wear, to the shirt that I actually put, and the things that I've consumed all through the day, including the water, has come out of some portion of a factory today, right? And if you just look at them and how that has been segregated across, right? There are multiple different variety of tasks that happens, from decision making to expertise being applied to data collection to data logging to observations, and then the physical labor, right? Where someone uses their hand to perform all of this. Eyes and hands, coordinated eyes and hands to perform all of this, right? And logistics for the case. So that is more than 31%. That's the largest chunk across every domain, right? Be it manufacturing, be it agriculture, be it transportation, right? Accommodation, whatsoever it is, that the human hand's presence is very high. And if it's just boiling down to the human hand, and then like we spoke about picking, orienting, placing is the task, we have obviously heard about robotic arms, right? There are so many robotic arms that typically are in the market, and we also have seen many videos of how those robotic arms are able to operate and then they're able to solve certain applications. But on the other hand, if you look at the size of the robotic arm, that's also not a small market. It's almost a $16 billion market, right? And what is more surprising is those robotic arms also need a lot of engineering around them. Somebody will have to go and do the programming, somebody will have to assist them, right? They are not like out of the box that you can actually keep it there and the system kind of learns and starts doing that in spite of the AI that we actually have, right? But that is the $32 billion, which is very healthy and quite significant. But that kind of pales when we compare with what's the size of just US market alone that it pays in terms of manual labor wages. And this is the most actively seeking, one of the most actively automation seeking markets, right? We can only imagine about the rest of the other countries like China and India and Japan and Europe and most of these places, right? And of course we have the data only for the US, and that's 1.2 trillion, $27 trillion, right? But that also brings another question. Could it be, how true could this be, right? How hard could it be, right? What is the perspective or the proportionality of the automation that happens, and where we stop, right? Instead of me speaking about it, I'll let the person who managed to bring the rocket and then land it back on Earth, right, speak about it, right? So if you just look at the man who managed to do the land the rocket back, kind of
here you can get a good sense for there's like General Assembly is what I was talking about as being really well suited to people.
Okay.
Because you got a lot of weird things that you got to put together. Like look at some of these assemblies that like it's pretty hard for a robot to like connect this on.
That makes sense.
Yeah, it's like depending upon how it comes out of the box, it could be like in a little different position. But it's pretty easy for somebody like, oh, it's like I just need to move it like an inch. Bolt it in.
It's probably really hard to write software to kind of know to adapt in all these different ways.
Yeah, so if you try to have the robot do this, you gotta have like a complicated vision system, and then like the vision system faults out. It's not quite right.
That's the hard part. We have a robot in our studio that moves the camera around, and the hardest part is when it faults.
Yeah.
You need a person there to know what to do.
Exactly.
For a man who managed to make an electric car which was invisible for almost 100 years, right, as a technology to percolate. On the other hand, technologically, something advanced. For you to even land back the rocket from space, this seems to be a hard problem to solve. In fact, that was reflected very well in his sequence of statements, right? In 2017, he had the Model 3 that has been released, and he had bookings over and above several hundreds of thousands of bookings that happened. And he was gung-ho, Elon Musk being Elon Musk, that we would be able to automation. I'm exposed to the level of AI that is there, and automation is something that we could do very well, and we should be able to address this demand. But a year later, they happened to do only 30,000 parts, right? 30,000 cars that they were able to release. And in fact, Elon Musk came out and then said that we underestimate the human capability, and we kind of overestimate the technology that exists for automation, right? And in fact, this tour that he has actually taken to his factory to explain what is actually hard and what is that the robotic arms are good at today, right? So as a part of it. So why exactly is this too hard for us to put together these weird things, right? So to study that, maybe we'll have to look at each of the stars that we actually saw before, right? I mean, it's all about picking, orienting, and placing, except that it's not just the hands that are doing the picking, orienting, and placing. It's often the scenario in which they are supposed to do the picking, orienting, and placing, right? Your environment is constantly being put into an unpredictable scenario, right? Behind these clean manufacturing places where you are actually doing all this precise placement of components and things, someone have to pick from a clutter from which they have come. If you have to do all this clean wiring and things that you have to do, the wires are always entangled. How do you understand how to put the wires together, right? And all this clean stack arranged warehouses from which the robotic arms can actually pick, if at all if it is arranged, behind them is this complicated scenario of all these plethora of the objects coming from their native places. From logistics, when they come inside, they are not going to come in arranged, right? And it's too hard for us to keep them all arranged, right? Even the way those things would be, even an of variations becomes a hard problem today, right? So they are all in unpredictable and cluttered environment. Now, if at all, to just see how the automation could happen for all of these things, when you have to kind of structure them, right? Here is a picture that is there on your screen. You can recognize the playstations that are there, and this is a PlayStation automation, assembly automation, where someone is manufacturing the PlayStation together, putting together the PlayStation. And if you just see that there is plethora of apart beyond that easily recognizable PlayStations, you also see a very complicated myriad of sensors, mechanisms, contraptions, right? Wires running through here and there, and each of this needs a phenomenal amount of engineering design or mechanical design that you have to do. The corner portion where you see, this is basically your robotic arm at the base, right? This is all your different kind of sensors and complicated engineering infrastructure. What could this be doing? Obviously, this has to be something for very complicated activity that they must be doing, right? Unfortunately, all that they do is just flip the PlayStation from a horizontal position to a vertical position. This simple action today actually takes so much of hardware, right? That brings another question. So if a robotic arm is there, why can't that guy go about directly picking that from there, right? So in fact, this is one very nice scenario, right? So if a robotic arm have to go and directly pick from there, here is a image from one of our customers where they have implemented it. So you see this blue color robotic arm here, right? So this is the robotic arm which is hanging from the roof upside down, and this is a processing machine, which is a CNC machine typically, right? Into which the parts are being fed into, right? And you have all these parts coming here, right? So this fellow will pick from this table these parts, which is engine casings, right? And cylinder casings, sorry, and they will be able to present them into the CNC machines for the processing that they are supposed to do. These are the cases where you are able to automate it, at all you are able to put a robotic arm. But behind that scene, right, what actually happens is this. There is a person who is actually picking those parts again from within those bamboo structure that has been put, and then he has to arrange them on a pre-built, customized conveying system, right? And the conveying system again goes and presents to the robotic arm. Obviously, that brings a question: why can't a person just directly pick and place in there? It's just about the amount of poke that you can put in this case, and how well and how organized could they get into in presenting these parts, right? So we need predictability and the precision. That's the major driver of robotic arms today, or the automation today, but they're still not yet there. There are some parts that you would not be able to put them in those arrangements and things, right? So without much delay again further, I'll again give it to Nikhil for next portion about what actually is behind it, what it would take for us to build these systems.
Right, so getting robots to really grasp a variety of objects and do tasks like how human beings do is not like a problem that we are articulating for the first time, right? It has been a dream for the world of robotics to always do this. In fact, ever since the first robotic arm was launched, probably 4 or 5 decades ago, we've been imagining that eventually robots will be able to do that. It's just that it has turned out to be such an elusive problem for the industry to solve. And for us to understand why it is so elusive, we have to go a little deeper into understanding where tech is today, how tech has been approached all this while. if you really look through the internet, you will see that there are quite a lot of players, and a lot of these players use different kinds of vision technology, but predominantly everybody rallies around 3D imaging, because you're living in the 3D world, you need to go grasp objects in the 3D world. So 3D imaging is required. You can construct 3D images using stereoscopy or different kinds of mechanisms to construct 3D depth map, and the assumption is that that is enough. But the challenge is that all of these 3D imaging methods gives you a fairly sparse depth information. In fact, the information that you get out of depth image is even lesser than the information you'll get out of a 2D color image. And because of this sparseness, what you're able to achieve at best is you're able to only work with simple geometry objects. And even when you're working with simple geometry object, you're only able to approximately locate an object, go touch that object, and you assume that if you touch that object sticks to the gripper, and then you can go somewhere and drop it. The moment you drop it, you lose the orientation of the object, right? So all of these solutions at best can do a touch and drop kind of a scenario, which is okay if the application is to sort from a randomized bin, but you cannot build a car, let's say, by dropping 10,000 parts at each other, right? When you're building a car, you need to pick every single object and then reorient and place them in very specific manner, pick boards, reorient and place those boards and assemble them very specifically. And the current solutions don't really scale to doing that, right? And again, from a methodology point of view, all of these systems, even if they're using vision, follow this typical paradigm. What you do is you acquire images, either 2D or 3D images, and then you train a neural network with a lot of static images that you had already previously obtained. And with that, you're going to train a neural network. And what the neural network can at best do is localize where that object is, probably draw the boundary of that object. And it is assumed that that kind of information is enough to give to a robotic arm, and then the robotic arm later just figures out how to go and pick, right? And this is fundamentally flawed. This is very different from how human beings work. Human beings have a lot more dynamic capturing. If we don't have the right kind of information about an object, we move, right? We look around, we are able to hold the object, pick the object, etc. This existing paradigm is also limiting because the vision and manipulation is assumed to be decoupled in this case, right? So the vision training happens separately, robot training happens separately, whereas human beings don't do that, right? Human beings, as a baby, we start hand and eye coordination is learned hand in hand, right? And that's how we really learn. When we are picking an object, we learn the object after picking the object, right? And that's something that we have as an ability that is unique. And most importantly, the assumption is that the world of vision is all about interpreting color, right? And that's a obvious assumption to make. Don't we see the world only on color, right? We interpret colors and we classify objects in the world through color. But to elucidate that probably is not enough. If you look at a cluttered scene like this, the scene of a market, there are so many colors, right? There are so many hues and shades of colors. If we went about classifying objects in what we see just based on color, these are the number of objects we should ideally be seeing, right? And in fact, at the earlier layers of our vision, we actually classify objects these many. But somehow our brain is able to interpret this complex cacophony of colors into these specific objects. The yellow and blue in the umbrella is classified as the same object, while the yellow in the flower is an entirely different object. How are we really doing it? There are fundamental layers that are beyond, and to elucidate one such layer, which is very, very fundamental, one more quick optical exercise, right? So what you see in this image or this slide is 3 images. And I'm telling you that in each of these 3 images, there's an animal, right? And each of these 3 images, the animal is at a different location. And if I ask you to find out where the animal is, it's very difficult for us to do that. We are constantly searching, we are looking around. And the reason it's so difficult for us to see is because the animal is camouflaged with the background. When I say camouflage, what I mean is that the color of the animal is probably very similar to the color of the background, so it becomes very difficult for you to see. So in the colored domain, you don't have enough information to understand where the object is or where the animal is. But the moment I show you the animal in motion, if you see the third image at the bottom now, so what you see now, you're able to identify where the animal is, right? And we are able to identify the head and the tail of the animal. And that's because we as human beings have something called as event imaging or temporal imaging, which allows us to extract information that are changing in the scene even if that information is not particularly significant in the color domain. And that's a fundamental layer that we have implemented with our vision system and our robotic system as well. And in this demo video, what you'll see is our robotic arm picking an object. And what you will see on the top left is the robot setup. It is designed to pick a mirror finished spoon. What you will see on the right when I'm pointing my laser is the event imaging output, and what you see at the bottom is what the camera sees, and then what a standard edge detection algorithm will really see. And what you will observe here is that we're able to extract information or the output of the spoon, which is a mirror finished spoon, effectively from the background. Even though the background is a fairly cluttered cacophony of colors, right? So if you just look at this portion of the video, you'll see that the background is extremely complicated. Standard edge detection algorithms don't really work, right? It's extremely difficult for you to extract, but the event imaging algorithm allows you to extract that fairly well. This is not just enough, right? Like when you're really dealing with objects in the real world, there are a lot of other parameters that the system must cumulatively learn. Color is not the only information that one learns. To manipulate an object, you need to learn the shape of the object. You need to learn the size and the rigidity of the object, whether it's a squishy object or whether it's a solid rigid object. What is the surface parameters of the object? Is it a very smooth object? If I'm picking the object, is it going to slip or not? And most importantly, you also at any point of time understand the location of the object. You also need to understand the orientation of the object, and this orientation is the most difficult part, right? Because the moment the orientation of an object changes, as you see in the last image in the series, the shape of the object as you perceive it constantly changes, right? So for any complex object from different orientations, you have infinite possibilities of shapes, and that makes it an perpetually challenging, a perpetual training exercise if you really go about training for every single orientation. And this is one challenge that the world of automation has not been able to solve. So far, we've been focusing only on understanding color and location. And with that, you can do a few set of applications. But the moment you start learning the entirety of the object model, we will be able to solve use cases much more complicated. And to just give you a very quick glimpse, I have one demo video in the next slide. But fundamentally, the technology that we have built is a hardware layer on the vision side, which closely mimics the human eye. So we have autofocus optics and convergence, which allows us to move our eyes towards and further away from each other. And with this, we're able to interpret the different parameters of an object. We've also ended up building the world's fastest and highest resolution depth perception system in the process. We also integrate this vision with touch and force sensitivity. So we understand the physics of the object more than just the visual parameters of the object. And because of these layers, what we're able to do is grasp objects or do tasks on objects that were previously not possible. In this video, again, on the left part of the video, you see one of our team members playing with the robot. He will be presenting different objects to the robot. On the top right, you see one of the cameras, what it sees, and the bottom right is what the event imaging algorithm really sees. And you will see here that the robot dynamically tracks objects. Even if the background is fairly cluttered, you see people, you see different kinds of objects, this background is constantly changing, but still able to track the object. And the best part is that none of the objects that are being presented to the robot today have been previously trained on. The robots have never seen these objects, but still we are able to do basic grasp, regardless of what orientation you're giving, even if it's a mirror finished part, or even if it's a part like this lace packet, which is very flexible. It knows how to adjust the force and not really pop the packet out, and that we're able to do because of how we interpret these objects. We have a hierarchical way of interpreting depth, and also event imaging allows us to extract information out of the background, only focusing on the changes. With this technology, you can open up a lot of possibilities, right? So on how this technology will become very, very fundamental in opening up a new paradigm for automation, I will hand it back to Gokul to talk about how this is going to be the genesis of the future in robotics.
To bring about a vision of what this could do. Okay, so there is a robotic arm, there is something that is actually having as a vision system, and probably most of the details of it. we will understand much more in depth once we come inside, once get the exposure to it. But what can it actually do? What is this manual labor change that we're talking about? What is that we are talking about from a manufacturing point of view? Right? So to understand that better, I seek the help of an analogy, right? So in fact, this analogy is pretty much true and very closely related on the basis of physics, as fundamental physics, right? We have seen the world that we know today, right? So all of us are programmers, all of us use laptops, all of us use a lot of different items around us. And data is the biggest talk that we have today, right? The next oil is data is what people actually keep talking about. And if you look at it, they all begin in the format of signals. Right? Somewhere or the other, it's a real world signal that we have captured, converted them into whether it's a touch, somebody's thought being typed out as a physical touch onto your laptop, on your keyboard, or me talking right now. There is a video of us. That's light as an information, sound as an information is coming through all of you when you are actually having a live event that's happening. So all these signals are being captured in different formats and they are being converted on using a tool which kind of processes and converts them right into your ones and zeros and data, right? So and that's being sent to a very common platform, right? All of you might have a very different laptops in your home. I have a very different laptop in my home. Right, in my place right now, I'm having an iPad that I'm using, I'm having a laptop that is actually hosting this, and each of them are all different form factors, yet they're fundamentally very similar as a system. They're standardized. That's how the same data is being interpreted and then being consumed on the other side, though the generation point is entirely different, right? The kind of camera that I might use is very different, right? And you have, how is that happening? First of all, we have a standard hardware platform on top of which we also have invented the code layers or program layers which are abstracted, which is able to enable them across multiple devices, right, to run or interpret this data. With this, what you are getting is something that is meaningful, something that is utilitarian, something that you could use and then have some understanding about it, information, right? So this is getting all processed, converted, and then formed into an information that you might need at your end, right? The same way, can we imagine all this variety of different objects that we actually had, right? So all this variety of different signals that we had, a touch, a physical force, keys being put in there, voice being there, light being there, ones and zeros of various formats being there, all being processed by one simple single system as a combination. And you need all of these parameters together. Similarly, if you just think about a variety of different objects, right, that we might have, we first have to form a model of those objects, just like you formed a data model of your signals, right? That is overlapped with the standard set of tools sitting on top of it, right? And we have something called as a work model that actually comes, right? So I had tools on one side, which is my laptop. I had signal on the other side. Your program is nothing but how they both must interface with each other. If they interface this particular way, it will lead to my meaningful utility or my data or information altogether, right? So that exactly is what as a sequence that happens typically in your object processing unit. Just like we have a central processing unit, if you have these actions that is performed, which is a standard thing that is happening across any task that you take about you cooking something where you're cutting vegetables, you're taking vegetables are nothing but your objects that you want and the tools that you use to cut it, and the pans and things that you actually use are all your things, and how to operate on top of them, and then that becomes your meaningful dish at the end of the day, right? What you wanted as a final outcome at the end of the day, right? Or you wanting to pick a pen that is lying there somewhere, and then you wanted to pick it and then bring it to your expected orientation, which is your hand that you're using as your tool, and then you're continuously writing, which is a work model that you're doing. The result is whatever that you wanted to scribe as a thought on your paper, it comes out as that, the paper on the ink with a meaningful pattern on top of it, which you could interpret, right? So every task if you take seems to be very commonly broken in, can be structured. If it can be structured this way, right? What kind of transformation can we actually see, right? This is very interesting, right? We have seen in 1980s and 70s and probably early 90s, right? How many different devices that we actually had for processing every variety of information that we used to have. For calculating numbers, we had calculator. For sending a data as a document, we used to have a fax machine. To make a copy, we used to have a Xerox machine, right? To have, we had calendars, right? We used to have gramophones, we used to have telephones, we used to have radio, we used to have television, right? Imagine all those devices being blended into just, why did we have, first of all, why did we have all those devices? Because each of them have very different data. So if I had a very different data, very different signal, then I have to have very specific devices to it, right? But the moment they had been merged into one particular laptop or one particular device, somehow we figured out how to do that. And that transformed the economy that we have today. They transformed the world as we know today. The possibilities today, we are just, I'm sitting here and then you are sitting somewhere else, and then we are conversing about how you're going to join this company and what could you do here. This would have been impossible in 1970s or 80s or 90s or even in 2000s, early 2000s, right? This has become so phenomenally possible because we were able to generalize the laptops, generalize the system. How did they do that? They kind of understood that first I need to make a model of each of the data, and all data, if I see, performs only two tasks. One is arithmetics, the other is logic. What does arithmetic do? It removes or adds something to your data, whereas logic is just routing them between these actions in a repetitive sequence, right? They say it's an arithmetic and logic unit. The moment I am able to bring that and the supporting ecosystem standardized, I was able to build a CPU, and that became the genesis point of your laptops and computers, which could become a common form factor or a platform, right? We are at the same genesis for an object, right? In fact, if you think about an object store, just like you have an app store today, what could I actually have in that? First, I can form a model of object. If I have learned one bolt somewhere in one place, right? I have a digital representation of that model into my system, right? And I own that, right? And if I also have to make a model of those tools, then I can actually form another model called work model, right? So this is basically your, how whenever I see that particular bolt, I see that spanner head, where should they actually make? How should they actually make? Because after I make the object model, the task that I would do might be very, very different, right? So this is a combination. Extrapolate this for a scenario of a food. I'm just making one example, taking one example of food, right? Let's say you visited Indonesia, you visited Thailand, you liked some curry, you liked some dish over there, and that guy has set up a restaurant and he's so unique because he has figured out a recipe, not because he knows how to cook. If he knows how to cook, he would have become a chef, right? He's opening up a restaurant because he has a unique taste that he has actually invented. What is the taste? The taste is nothing but a combination of your objects and the tools that he actually uses on top of them. And how do you operate the tools on top of it? Did I put the masala first? Did I put the pan next? How much did I heat the pan? How long did I keep it on that? And how did I do that? This is all work model that you have. You have these combinations. Imagine at some point of time, today with this combination, he is able to make the very tasty dish. But if you want it, you come back to India, and then you don't have the restaurant here. And if you want it, the only way by which you can consume is either that guy will have to invest a lot, open up a restaurant here, put up people here, manage all of that, and then he has to serve you, right? Which means he has bare minimum number of customers that is needed, or you will have to go again to Thailand. This IP or knowledge of something is not able to, like AFC does, you are not able to franchise it. You have to create a franchising model. Instead, if I had a laptop, or if I had something like a laptop which you can just pass in like an email onto this, and then you suddenly are able to convert that into something and then into a consumable format, like a light and video that you're seeing. It can be a taste and food that you can actually eat, right? It is that perspective that opens up, right? That if you are able to invent something there, and he also has the robotic arm and the system in that place, and we also have a similar robotic arm set up in our home because it's affordable and cheap at one point of time, what could it actually transform into? How people will be able to create these things? You want a plumber, the plumber could sit somewhere else, you just have to, he will just guide you to position something somewhere. It's a science fiction obviously that we want to get into, but you just have a model and then you upload the model, and for his knowledge to be able to fix this, he could actually be remunerated without having to physically be present there. You could address a lot more customers at the same point of time, rather than having to, with the skill set, rather than his skill set being localized because of his demand to be present in that particular position, right? So these are phenomenal, explosion of value that you could actually create in this case, right? With this, there are other ancillaries that would happen today, right? Today we don't search on the basis of objects, we search on the basis of what we have as color, right? And because at the best Google has come up to is images, that you can do an image search, right? Or a voice search. But when do we get into an object search, right? What do I mean by object search? You go to an Amazon today, you are trying to buy certain items from Amazon. What do you see at the bottom? You see all the associated products that you can buy. On what basis do they populate that? They populate that on the basis of how many other people and what pattern did they buy along with it, right? But instead, if you want to say that, hey, I want to see all the bags that are textured this way, which is soft, which is a velvet cover, or the zip of this sort, right? That's something that's not feasible today, right? Could I search the parameters of the object as I could describe it, right? To do that, what is lacking today? Because most of these NLP systems do not understand verbs. They can understand nouns, right? But they have never experienced verb. They don't know what it means to catch a ball. They don't know what it means to bounce a ball, right? If I apply this way, will it bounce more or will it bounce less? This is what stops them from having a conversation, right? Otherwise, you're just borrowing words and then just filling in patterns of sentence making, right? You're not making a pattern of how it could be imagined. If I'm saying a barber cutting my hair, how is he cutting the hair? What is it cutting the hair means? There are a lot of facilities of details that you cannot imagine today because they lack understanding of verb. Why do they lack the understanding of verb? Because those systems cannot go and perform any task typically, right? It can now, if I'm able to understand verbs, it extends also towards driverless cars because I can understand motion and movements, right? So just like we had, even imaging these things, right? That also further extends to what you could do from an AR, VR perspective and what you could do with an immersive entertainment perspective. Imagine you could walk into a movie instead of you having to see the movie only in one perspective, right? One vantage point, what director shows. What if I want to just go there and then in one time I want to see like that particular character, how the world is, right? In another time I just want to see how the other world is, right? This kind of makes a movie, even a single movie, to be a lot more explorative and a lot more possibilities to be built an alternate world. In fact, recently this metaverse has actually started coming as a point, right? So that's something that is quite interesting for us to again see where that would get into and how we could contribute to that sector as such. Okay? If now we look at this, how disintegrated this robotic arm market was with our product, maybe we could have simplified this into one unified market where people don't go about customizing and building it, but they can off the shelf buy this robotic arm as one system and then start programming on top of it and start deploying it. But beyond that, also often when you solve something like that, when you standardize it, there's a larger market that opens up. Even outside of China, we have $80 billion market that actually opens up, right? So for us to do a lot of these activities, maybe we may not be able to do the kitchen thing today, but 10 years down the line we'll be able to do it. But today we can open up a market, which is $80 billion worth of things if we are able to get this to the market and then start solving this. So that is the next big thing that we actually talk about. It's not just our words. In fact, what other stalwarts might be thinking from this point. So luckily enough, some of these things have been registered in the public forums. So in 2016, when Bill Gates was in Reddit asked me anything, when he was asked about what's going to be the next big thing, he goes about saying that robotic arm, which has vision as good as human being, to be able to manipulate objects as good as human being, will be the next big thing, right? And we underestimate that. In 2019, again, Jeff Bezos also chimes in for the same point, saying that this will be the next big thing to open up into the market.
And that's all for today. Thank you. Hope you enjoyed and stay tuned for more.